Okay, so far we have covered 2 weeks. First week we covered the introduction, first 3 lessons. Next week you were introduced to search algorithms, and in the last class, towards the end of the week, what we discussed? We discussed heuristics. What is the meaning of heuristics? And we discussed about, we solved some numerical problems, and 3 kinds of heuristic methods we discussed. What were those? What were the heuristic methods that we discussed? 3 methods we discussed. One is Manhattan distance. Okay, that is also called taxi cab distance. The second one is Hamming distance. Hamming distance means number of misplaced tiles or errors. Number of errors. That is Hamming distance. And the third one is, which we did not use, but it is the idealistic one, the Euclidean distance. Okay, the minimum distance. So these 3 heuristic methods we discussed, and we discussed that heuristic means, what is heuristics? What is the meaning of heuristics? Anyone? What is the meaning of heuristics? Okay, when we transition from uninformed search to informed search, what is the requirement? Yes? Shortest distance. Yes. Then? Initial? The distance between initial to goal state, or we say an estimate of the cost. It can be in terms of distance, it can be in terms of, say, kilometers traveled, okay, or it can be in terms of ages, graph ages, okay. So that is the estimate that we require. But how to estimate? In pure optimization problem, you have a mathematical model for that. Okay? In pure optimization problem, for example, cost minimization in generation. So you have a quadratic cost function. That is pure optimization. But in this case, we do not have a priori information regarding the mathematical model of the distance. So how to estimate it? So what we do is, we devise our own way of doing it. We devise our own way of doing it based on the situation. Suppose you wake up early in the morning in the hostel and you see that there is no water. Okay. So in that case, on that particular moment, you devise a plan. That is called heuristics. So that doesn't mean that that will be written in the, these people are taking admission there. So in the manual it will be written, if there is no water in the hostel, follow this. So in that case, many of them won't take admission. Okay, so we cannot do that. So this is heuristics. Heuristics means you create a solution based on the nature of the problem. Okay, that might be applicable for other domains also. That might be applicable. Now, when you have a lots of problems and lots of heuristics, then some heuristics are reusable. Okay, some heuristics are reusable, but not necessarily. So that is known as heuristic. So what is heuristics? The definition, a commonsensical definition of heuristic is finding a solution based on the nature of the problem. Right? Finding a solution based on the nature of the problem. That is known as heuristics. Okay. In your soft computing and optimization topic course, the last 2 modules were about genetic algorithms and PSO, particle swarm optimization. So those 2 algorithms of optimization are nothing but heuristics. Okay. So based on the nature of the problem, okay, you create a swarm of particles, okay, and you give them some heuristic measure, and they optimize the heuristic measure. Okay, that differ from problem to problem. Okay. In fact, when we go to industry, say for example, this machine design. Okay, machine design. So it is not that whatever you are studying in the book, electrical machines 1 and 2, after that you can design a machine. No, it cannot do that. Every technological innovation is a iterative process. I think Tejas aircraft, indigenous aircraft, we took 20 to 30 years for building it, because iteratively we improved the design, right? We improved the design iteratively. So after some time, our design is perfect. So every time we face a failure, we provide a solution. That is a heuristic. Okay, that is a heuristic. So that solution worked only for that aircraft. It may not be applicable for some other domain. Now problems arise when we apply heuristic measures of one discipline to other discipline. So nowadays, suppose you apply mathematical optimization algorithms to economics, which is a socially, which is too much impacted by the society. So in that case, failures may occur. Okay. So you cannot apply the heuristics of engineering to solve a science problem. Okay. It's generally not possible. Heuristics, if reapplied, are generally applied to the same domain, not to a different domain. Generally. Okay. So that is known as heuristics. Now, so this is Manhattan distance or Euclidean distance or Hamming distance. Three distances we have measured, and these distances we denote as Fn. So the function that we use here is known as Fn. Now this Fn, as I said, it is not fixed. It is a simple, it can be any formula, it can be any distance. Okay. Now best first search is an informed search which will utilize this heuristics Fn. So only by utilizing this heuristics Fn, the search method is known as best first search. It is an informed search. Today's class, I told you in the lab, you are supposed to do it. Now, if you add another one, you might have read also. So if you do Fn plus Gn, two heuristics you add. In that case, it is called A star. Okay, A stands for algorithm and star for optimization. You might have seen when we find a solution, optimal solution, we make it star, F star. Okay. So A star is algorithm star. A stands for algorithm. The algorithm name is A. Okay. A star. So that is Fn plus Gm. It is also a heuristic algorithm. Now, what is AO star? Now, AO star is a modified version of A star algorithm which is applied to a specific kind of problem known as AND or graphs that we will discuss in the next class. Okay. So today's our objective is that you should be thorough about the best first search. That means you should know how to depth first search simply goes to the depth. Breadth first search simply goes in a breadth first manner. Whereas best first search will go to the next node only when the cost is minimum. If our objective is minimum cost. Okay, or the distance is minimum. Right? So this is your experiment 2 in your lab. So we are moving to informed search, and the prerequisite of informed search is, what is the prerequisite of informed search? You should know what is heuristics. Okay. Heuristic is basic information presented in a form that is suitable to the domain. So that is known as heuristics. So informed search strategies. Uninformed search methods are exhaustive methods of finding paths to goal node. Search expands too many nodes before solution. Okay. Now you see, when you face a problem in real life, a human when faces a problem in real life, first of all, we don't apply optimization. Optimization means mathematical optimization that you have studied in the third semester. Do you do that? Do you model suppose somebody asks you to fill up the tank, okay, fuel tank, you are moving. Do you apply simple optimization technique? Okay, this is the distance subject to all the road conditions, I will put up this much fuel. We don't do that. So we don't use mathematical optimization in real life. So if human intelligence is not using it, why should AI use? So AI doesn't use optimization. That's for sure. Next comes AI uses search, simple search. Okay. So as a human being, what is your first intuition when you face a problem? You actually do uninformed search, right? When we face a problem, we either do a depth first search or we do a breadth first search. depending on the nature, depending on your background, your nature, your aptitude. Some people will try to delve deep and some people will try to stay just make the breadth as good as possible. Many of you are maybe focused on getting the best of electrical engineering. Some of you may be interested in giving a breadth of knowledge, reading newspapers and all these things. Okay, so that is completely intuitive. Okay, that is one extreme. One extreme is mathematical optimization, with everything defined mathematically, which neither human uses nor AI is supposed to use. The other extreme is uninformed search, which humans use mostly. As you get more and more experienced, you actually use intuitively heuristic search. But at your stage, many a times you are actually using uninformed search because you don't have any information. You simply take the next random step. Okay. So here, these are exhaustive methods. That means learning from experience. That is actually uninformed search. Right? Learning from experience. Failures, those are uninformed search because we did not know. Search, but what is the problem with the uninformed search? Okay, for example, you expand too many nodes. Okay, now suppose you are built for a particular career. Now, because somebody else is preparing for GATE, you also start preparing for GATE. Eventually, you fail. After that, you go somewhere else. So, it took you 4 to 5 nodes to explore 4 to 5 nodes, career paths, finally to settle somewhere. Okay, whereas because it is uninformed, you are not very aware of the costs involved, okay, or the heuristics. Next, however, informed search uses task-dependent information to help reduce the search. So, when we are informed, suppose you have a very good guide, okay, in your parents or in your teacher, in your friends, in your siblings. So, if you have a very good teacher, in that case, he will simply tell you, don't explore those nodes. So don't go in that direction at all. You are meant to go in this direction. In that case, your search space gets reduced and you reach your level at the minimum time. Okay. So this information is called the heuristic information. That is the information that is given to you by your mentor. That is known as heuristic information. Then you have got bad heuristics, good heuristics. Suppose you have a bad mentor. So in that case, you get a bad heuristics and here the cost is even higher. Okay. Now, what are the types of search? Heuristic search. So, best first search. Okay, first we will see the plain best first search. Then we will move to A star and its expansion AO star. The other one is hill climbing and simulated annealing, which we have discussed in the last class. That is the intuitive heuristic search. Okay. Some combinations of cost of the path, which is Fn, and cost of the search, which can be considered to be GM. Okay, so if you combine both, it is A star. If you take only one, that is best first search. Hello? Search expands among most promising frontiers. Most promising frontiers, because what is frontier? Frontier means which is at the most ahead. Frontiers of technology. Okay, that means the state of the art. Okay, which is the most ahead technology. So you go to the frontiers easily because you have information which path to follow. Now each state is assigned a heuristic value, okay, that the search uses in deciding the next best state. So what is best first search? It is a way of combining the advantages of both depth first and breadth first. We actually do both DFS and BFS. So what DFS does? DFS allows the solution to be found without all competing branches having to be expanded, whereas BFS does not get trapped on the dead end points, right? When you do depth first, there are chances that you get trapped because you go too deep. Just like you start a solving question in the GATE exam. Now you are stuck, but since you have already given so much time, you tend to give more time to that question. So you get trapped. So in that way, you leave many. That is the problem with the DFS. Okay. So if you combine both, but switch paths whenever some competing paths look more promising than the current one. So best first search uses an evaluation function Fn for searching each node and find the desirable node. Special case is A star, which uses Fn plus Gn. Okay, A star is a special case of best first search. Okay, BFS or best first search prioritize exploration by using domain specific knowledge, which is called heuristics. Say it, which is called heuristics. ସମସ୍ତେ କହିଲେ ଦେଖିବା heuristics. Okay, heuristics କହିପାରୁଛ କି ନାହିଁ ଦେଖ କହିପାରିବି ତ ମୁହଁରୁ ବାହାରୁନି heuristics. Okay, so if somebody asks you तू ए स्टेप टा काहे कि नेलु heuristics सल्ला से चुप ହେଇଯିବ ଆବେଶ ପଚାରିବନି अरे किसी भूल ହେଇଗଲା ତମକୁ କି ପଚାରଲା କାहे ଏ डिसीजन ଟା ନେଲା ଏଟା ଭୁଲ ଥିଲା heuristics ସେ ବୁଝି ପାରିବନି ପଡିବ मन रख इट्स ए गुड नाइस वर्ड ओके इट्स ए ग्रीक और लैटिन आई थिंक okay evaluation function so what is evaluation function a mathematical formula used to calculate the score of a node heuristic function an educated guess see heuristics are all guesses right unlike mathematical optimization when you have a crisp formula heuristics are simply guesses okay